from Monday's session posted on Canvas. I just have to buy a moment of time to get that done, and I will try like heck to get it done when I get off of here this evening. And I'll post the Monday lecture, and I'm going to try like heck to post this lecture too, because I know some of you really rely on those recorded lectures quite heavily. And so I will get that to you. Okay.
Do you
All
know
right.
what quiz will be graded?
Yeah, your first quiz. Yeah, I am. My schedule is extremely busy now, but I am going to, work on those and get those graded. And I'll probably try to get those graded by no later than by Friday morning. Okay. Friday morning. All right. So hopefully you all did quite well on the quiz. Hopefully we'll find out. And of course, I will give you the solutions to that quiz. And I will also give you eventually the solutions to the exam too. And for that reason, you want to keep your work for your quiz or your exam. Don't throw it away, but keep your work for your quiz or exam. And then, compare your problems with the solutions that I send you. Because if there's any discrepancies, you'll see like where the errors occurred. Okay. All right. All right. So section 3.3, what are we going to do in this section? Well, we are going to learn another technique for graphing a linear equation in the XY plane. So another way to graph linear equations . 2 days ago, we looked at what method. Does anybody remember the method we used in section 3.2 to graph linear equations? We already looked at what technique?
Was it the table method?
Yes, we already looked at what's called the table method for graphing a linear equation. That's where we make a table and then we start choosing some values for X, correct? And then computing what Y is in order to generate ordered pair solutions to our equation. After which we then plotted them in the plane and put a line through them, okay? There is another way to graph a linear equation, and that's what we're going to look at in section 3.3. All right, suppose I had a linear equation and I graph it in the XY plane. And suppose that the graph of my linear equation, ladies and gentlemen, looks like this. Now, I don't know what equation generated this graph, but just suppose I had some sort of a linear equation in X and Y, and I graphed it in the XY plane, and suppose the graph looks like this. Now, the point of intersection between the graph and the Y-axis, that point of intersection has a very special name. It's called the Y-intercept of the linear equation. The Y-intercept. The point of intersection between a graph and the Y-axis is called a Y-intercept. Equally important is this point of intersection between the graph and the X-axis. It is called the X-intercept. Of the linear equation or the graph, okay, X-intercept. All right, so it is a fact that X-intercepts are points that always lie on the X-intercepts are always points that lie on the X-axis. A Y-intercept is always going to be a point that lies on the Y-axis. And of course, again, those points mark the point of intersection between the line or the graph and the respective axis. Let's look at a y-intercept. Because a y-intercept is a point that lies on the y-axis, its x-coordinate must always be equal to what? Anybody want to guess as to what the x-coordinate of a y-intercept must always be equal to? Ladies and gentlemen, in order to be on the y-axis, a point's x-coordinate has to always be 0. So if y-intercepts always have an x-coordinate that is 0. To qualify as being an x-intercept, a point that lies on the x-axis, what must the y-coordinate be for an x-intercept?
0.
0. Because an x-intercept is a point that's on the x-axis, its y-intercept, its y-coordinate has to be 0. Otherwise, the point will not be on the x-axis. It's going to be above or below the x-axis. So x-intercepts always have a y-coordinate that is equal to 0. Does that make sense that would be the case? So x-intercepts always have a y-coordinate of 0. A y-intercept always has an x-coordinate equal to 0. Always true. Well, if that's the case, ladies and gentlemen, then that would provide a what? Another way of graphing a linear equation. If we could find the x and the y-intercept of a linear equation, we could plot those 2 points. We could then put a line through those points, and we would therefore have the graph of the linear equation. Okay, so we would have the graph. So x and y intercepts are very important, and in scientific applications, they actually have relevant meanings. Okay, important meanings. Okay. All right, I'm going to go to our textbook here. This is also illustrating a y-intercept versus an x-intercept. Notice for a y-intercept, the x-coordinate is always 0. For an x-intercept, the y-coordinate is always 0. Okay. Everybody see that there? All right, so let's go right down here and see if we can start entertaining a couple problems here. So section 3.3, these problems start on page, let's see, on page 214. 214 in your textbook is where these problems begin. All right. For this first set of problems here, 1 through 22, they give you a linear equation. And they want you to compute the x and the y intercepts for the following equations. And then they want you to use the intercepts that you computed for the equation to actually graph the equation. All right. So, see if we can do a couple of these here. All right, so I'm going to look at like problem number 2 here, where they give us a linear equation, which is 2x plus y equal to 2. And they want us to find the x and y intercepts. So let's find the x-intercept first. What do I set equal to 0 to find an x-intercept?
Y.
Y. So we always set the y variable equal to 0 to find an x-intercept. And the reason why that is, again, is because an x-intercept must always be a point on the x-axis. And any point that's on the x-axis always has to have a y-coordinate of 0. Otherwise, it won't even be on the x-axis. All right, so we take 0, substitute it in for the y variable into our equation. And then upon making a substitution, our equation would collapse down to 2x plus 0 equals 2. And now we're going to solve for x. So how do I solve for x here?
Just divide.
Divide by 2.
Divide both sides by 2. And when we do that, we're going to have x, or 1x. And that's going to be equal to 1. All right, so our x-intercept is 1, or as an ordered pair, what would my x-intercept be as an ordered pair? Anybody?
1, 0.
All right, it would be 1, 0. You are correct. It cannot be 0, 1, because 0, 1 would be a point on the y-axis. This is an x-intercept, so this point has to lie on the x-axis. And because of that, yes, remember, x coordinate comes first and then the y coordinate for any ordered pair. So it has to be 1, 0. That's your x-intercept. Let's now proceed to find our y-intercept. What do I set equal to 0 to find the y-intercept?
X.
X gets set equal to 0. Because a y-intercept is a point that lies on the y-axis. And any point that's on the y-axis must have an x-coordinate that is 0. Otherwise, it won't even be on the y-axis. So let's take 0, substitute it in for our x variable into the equation, and then our equation becomes 2 times 0 plus y equals 2. Now we can solve for y. 2 times 0, this has gone to 0, and we're left with y equals 2. So as an ordered pair, what would be my x-intercept, excuse me, my y-intercept? What would it be as an ordered pair?
0, 2.
All right, so it would be the ordered pair 0, 2. All right, not 2, 0. Remember, x coordinate comes first and then the y coordinate for ordered pairs. So it would be 0, 2. Everybody see that there? Okay. Now, ladies, 2 days ago, I said 2 points are, bare minimum to determine a unique line in the plane. But I also indicated 2 days ago that it's better to use not 2 points, but how many points?
3 or more.
3 or more points, okay? It would be great if we could generate a third ordered pair solution to this equation, because that just means when we go to, graph this equation, it's going to be a more accurate graph as opposed to just using the 2 intercepts, right? So can somebody give me another nice value for x that I could substitute in my equation to solve for an y, another ordered pair? What would be another nice value for x? Can you give me another nice value?
4.
So we would like to find a third point. Third point. And what did you say we could use? X equals I don't know, maybe you could choose x to be like 2 or something. If x is 2. If x is 2, we'll substitute 2 in for the x variable in the equation, in which case we'll have 2 times 2 plus y is equal to 2. And now, how do we solve for y here? 2 times 2 is 4. And then we subtract what? 4 from both sides? 4's drop out here, and we're left with y is equal to, what's 2 minus 4? -2. So what's another point that I found, or another ordered pair solution that I found here? Anybody?
0, -2.
Well, how did I get -2 for y? What did I put in for x?
2.
No,
So-
positive 2. So
Yeah.
another point that would be a solution to this equation would be 2, -2, correct? There we go. All right, now that we have 3 points, 3 unique points, we can, that sit on the graph of our equation, we can plot them and look at the graph of 2x plus y equals 2. And so what we would do next, or I would strongly recommend you do next, is take out a piece of, what kind of paper is this? Graphing paper, Liz on. And so let's see if we can look at the graph of that problem there. So I'm going to make my y-axis, and I'm going to make my x-axis. Do that there. And I'm going to assume my tick marks are spaced 1 unit apart. 1, 2, 3. Okay, 1, 2, 3. Right, -1, -2, -3, -1, -2, -3. Okay, so let's plot these points here. So what was our x-intercept? It was 1, 0. Let's plot our x-intercept 1, 0. Start at the origin, and I move 1 to the right and stay right on the y-axis because my y-coordinate is 0. There's my x-intercept 1, 0. Now we can plot our y-intercept, which is 0, 2. We start at the origin. I do not move right or left because my x-coordinate is 0. I just move up 2 units on the y-axis. So up 2. There's 0, 2 right there. So we got the point 0, 2 plotted. We also have the point 1, 0 plotted. And now we want to plot the third point we found, which was found to be what? Was 2, -2. So to plot the point 2, -2, we start at the origin. I go 2 to the right, then down 2, -1, -2. Does it look like these points lie on a line, ladies and gentlemen? Does it look like those points are collinear points? Are they collinear? Do they lie on a line?
Yeah.
Yes, it appears that they do, and there's no surprise there because a linear equation, a graph of a linear equation must always be a line. And so its solutions always have to be points that lie on a line. Take a ruler, put a line through these points, and you have the graph of that equation, 2x plus y equals 2. And that would be the graph of 2x plus y equals 2. And the method we used was the what method? We used the x, y, what? Intercept method. Right? We found the x and y intercepts. We did not use the table method. We used the x, y intercept method. Okay. Any questions with that problem? All right, let's try another one. That was one like number 2 there. Let's see. We could do one like number 12. Okay. So number 12, we have a linear equation, and they want us to find its x and y intercepts, and then use those intercepts to graph the equation. So we have -5x plus 4y is equal to 20. So there's our equation. Now we will find the x-intercept first. How do I find an x-intercept? What do I set equal to 0?
Why?
Y. Take 0, substitute in for your y variable, and your equation becomes -5x plus 4 times 0 equals 20. So y I replaced with 0. Now we must solve for x. We have -5x plus 4 times 0 is 0. But -5x plus 0 is -5x. Now how do I get x by itself? divide by -5. These -5s reduce out to 1, and we're left with 1x or x. And 20 divided by -5 is -4. Ladies and gentlemen, as an ordered pair, what would be my x-intercept as an ordered pair?
Negative 40.
-4, 0. You are correct. Mhm. Now we can find our y-intercept by letting what be 0?
X.
Take 0, substitute in for your x variable into the equation. So we have -5 times 0 plus 4y equals 20. Five times 0 is 0. 0 plus 4y is just 4y. Now to solve for y, what do? Divide both sides by 4. Hence we get y is equal to what? +5. So as an ordered pair, what is my y-intercept as an ordered pair?
0, 5.
0, 5. So we do have 2 points that we can plot in order to, eventually graph this linear equation. But let's see if we can find a third point. Can you give me another nice value for, let's say, x, Lazone? Now that's not obvious as to what a nice value is here.
2.
Okay, 2. All right. Now, notice if I choose 2 for x, this is going to be -10. Then I would have to add 10 to both sides, and I would have 20 plus 10 is 30. But ladies and gentlemen, 30 is not evenly divisible by 4. 2 might not be a great choice for x. Can anybody else give me another nice value for x?
Four.
Okay, 4. All right, we can certainly consider that. That looks like it might be a nice value. So finding a third point. We choose x to be 4. Take 4, substitute it in for the x variable, and the equation becomes -5 times 4 plus 4y is equal to 20. And now we have to solve this equation for y. This is going to be -20 plus 4y equals 20. How do we solve for y?
Add 20 to both sides.
Okay, add 20 to both sides. These 20s cancel out on the left side, leaving us 4y. And we have 40 on the right. Divide both sides now by 4. And this implies then that y is equal to what, 10? So what would be a third point that I found here? What's a third solution to this equation that I found?
0, +10.
Well, wait a minute, how did I get this 10? I put 4 on
10.
the right? 410.
Oh, sorry, I didn't see that.
410, yeah. All right, well, let's take these 3 points to the XY plane and let's see if we can plot them and get the graph of this linear equation. And so I will get my graphing paper out again. I'm going to make my graph maybe a little bigger this time because I don't know, it was hard to see. I thought it was kind of hard to see, but I'm going to make it a little bit bigger here. And I'm going to put my x-axis down here. All right, help me plot these points. Let's plot the x-intercept, which is -4, 0. So plotting -4, 0, I start at the origin. How do I move? -4, 0.
4 to the left.
4 to the left, -1, -2, -3, -4. Do I go up or down?
No, you stay on the line.
We stay right on the x-axis because the y coordinate is 0. That is the ordered pair. That is going to be -4, 0. All right, let's plot the other intercept, the y-intercept. It was 0, 5. Start at the origin, and how do I move?
Up 5.
Up 5. 1, 2, 3, 4, 5, right here. This would be your y-intercept. That's the point 0, 5. I think we had a third point, and the third point was what? 410? So how would we plot 410? Start at the origin, and how do I move?
4 to the
You
right.
move up. Oh,
4 to the right. 1, 2, 3, 4, and then up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, up 10. 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10. I'll put the point right up here. Does it look like these points are collinear points? Does it look like they lie on a line? Kind of looks like it, doesn't it? So we're going to take a ruler out. What do we do now? Take a ruler and do what? So I'm going to take my ruler and I'm going to put a line through these points. Make sure you always put arrows at the end of your line because it has to go in both directions forever. And ladies and gentlemen, that would be the graph of -5x plus 4y equal to 20. And what method did I use here? I used the what? The XY intercept method. Okay, classwork number 1. I want you to try one now. That was number 12. I want you to back up and do problem number 9. Classwork number 1, problem number 9. Okay, so see if you can find those intercepts and then graph the linear equation.
when you get a minute, can I see that graph again?
Okay, so to solve for x here for problem 22, what would I do?
Would you add? Is that right?
No, not add. How would you move a +2 to the other
Oh.
side?
2.
Minus.
Okay.
Let's minus off 2 from both
Oh, I
sides.
was gonna say subtract the fraction.
Now what's 0 subtract 2? 0 subtract 2.
-2.
-2.
Thank you. What happens to the 2's on the right side? They're gone. Now, how do we get x by itself? I got -1/3 times x. How do I get x by itself to solve for x here?
Divide
Okay, what would I divide by?
the 1/3.
-1/3? A negative 1/3 reduce out to 1 on the right side. 1 times x is x. Now on the left side, we have -2. That must be what? Divided by a negative 1/3. How do we divide fractions? Do we remember from basic mathematics how to divide fractions?
Do you flip it?
We change division to what? Multiplication.
And
And
flip
you're
the
right.
fraction?
I got to flip the fraction. So what's the reciprocal of negative 1/3?
3
Just-
over 1.
Negative 3 over 1, or just negative 3, correct?
Yeah.
Now, ladies on, what's negative 2 times negative 3?
+6.
There you go. So what's my x-intercept as an ordered pair?
6, 0.
6,
Wait,
0.
6, 0, yeah.
Good. Let's now find the y-intercept. And how do I find a y-intercept? What do I always set equal to 0?
X.
The x variable. Take 0, substitute it in for the x variable in the equation. So we replace x with 0 here. And therefore our equation will be y is equal to negative 1/3 times 0 plus 2. What's negative 1/3 times 0?
0.
0. What's 0 plus 2? 2. What's my y-intercept as an ordered pair?
0, 2.
0, 2. Let's now find a third point. Ladies and gentlemen, what would be a wise choice for x? Do you remember what I said a couple days ago? What would be a wise choice for x? Since we got negative 1/3 being multiplied by x. How about a multiple of 3? Do you agree? A multiple of this denominator. So we could choose 0. Well, not 0. We already did that. We could choose 3 or -3 or 6 or -6 or 9 or -9. All those are multiples of 3. In doing so, you'll get nice cross cancellation. You'll get a nice integer for y. Let's let x be 3. If x is 3, we replace the x variable with 3 in the equation. And so y will be negative 1/3 times 3 plus 2. Now, what's negative 1/3 times 3? Well, it's going to be negative 3 over what? 3, right? Negative 3 over 3 plus 2. But what's another name for negative 3 over 3? What does this reduce down to?
1.
Not positive 1, but
Negative.
-1.
negative 1. What's negative 1 plus 2?
+1.
What's another ordered pair that I generated as being a solution to my equation?
3, 1.
3, 1. Ladies and gentlemen, we have what? 3 unique points or solutions to my equation. We should be able to plot them and graph this linear equation. So take a piece of graphing paper and get yourself a ruler. And then I'm going to plot these points here, okay? 6, 0. How do I plot 6, 0, the x-intercept? Start at the origin, and how do I move? 6, 0.
You move to
right.
the right.
6 to the right. 1, 2, 3, 4, 5, 6. Don't go up or down because the y coordinate 0. 6, 0 is a point on the x-axis. That is our x-intercept. All right. Okay, so that's 6, 0. Let's plot the y-intercept, which is what? 0, 2. Start at the origin, and how do I move? 0, 2.
Up 2.
Stay on the y-axis since my x coordinate is 0, and just go up 2. 1, 2. There's my y-intercept, 0, 2. Finally, let's plot our third point, which was what? 3, 1. start at the origin and how do I move the plot 3-1? How do I plot 3-1?
To the right, 3, up 1.
1, 2, 3 to the right. Now up +1. 3-1 right there in the first quadrant. Certainly looks like these points lie on a line, as they should. Take a ruler, put a line through these points, and ladies and gentlemen, you have the graph of that linear equation. There's the graph of y equals -1/3 x plus 2. That's its graph. Does that make sense how we're graphing using the intercepts linear equations? All right. So that's what happens if you have a fraction. Just choose nice values for x. All right, let's move on. Now here, with these problems, 23 through 28, excuse me, they want us to find the x and y intercept and then graph these equations. Let's choose a problem here. And it doesn't matter which one, they're all pretty much similar. I'll do problem number 28 here. The equation is y is equal to 3/2 times x. And they want us to compute the x and y intercepts for this linear equation. And therefore, how do I find an x-intercept? What do I always set equal to 0?
Y.
Take 0, substitute it in for the y variable in the equation, and we have 0 is equal to 3/2 x. Now, how do we solve for x here? How do we solve for x?
Divide.
What's that?
Divide.
Divide both sides by what?
3/2.
Okay, 3/2. The 3/2 on the right side reduce out to 1, and 1 times x is just x. What's 0 divided by any non-zero real number?
0.
0. So what's my x-intercept? What's my x-intercept?
0, 3, 2.
0. Wait, what's my
I
y
mean-
coordinate?
3/2.
No, my x coordinate is 0.
0.
But what's my
0.
y coordinate? 0, 0, 0, 0. This point has a special name. It's called the what of the xy plane? The
Origin.
origin. All right, let's try to find the y-intercept. What do I set equal to 0 to find the y-intercept?
X.
Take 0, substitute it in for the x variable into the equation, and therefore we're going to have y is equal to 3/2 times 0. Well, what's 3/2 times 0? What's anything times 0?
0.
What's my y-intercept?
0.
0, 0.
Yep.
Ladies and gentlemen, what's going on here? My x and y intercepts are the same points, 0, 0. Is that enough information to graph this linear equation? Are these two unique points?
No.
No.
They're
You
not
don't have
unique.
no line, right?
Well, they're the same point, aren't they? The x and y intercepts are the same point. You
Right.
you cannot graph a unique line in the xy plane through only one point. So we're going to have to find how many other solutions for this equation are we going to have to find? We only have one, 0, 0. We got to find probably what? How many more at least?
2.
2 more. Give me a nice value for x, ladies and gentlemen. Notice it's 3/2 being multiplied by x. Give me another nice value for x so I can find another ordered pair solution to this equation.
2.
2 would be a great choice because 2 is a multiple of this denominator. So let's let x be 2. Therefore, y is going to be 3/2 times 2 or 2 over 1, which gives me 6 over 2, but 6 halves reduces down to what?
Three.
What's another point that I've generated for this equation?
2, 3.
2, 3. Give me another nice value for x. Another nice value for x. 2 is a beauty. Give me another one. Give me another multiple of 2.
4.
4 would work, or -2 would work, or -4 would work, or -8 would work, or +4 would work, or +8 would work. Okay, you want to go with the what? 4? Let's let x be 4. If x is 4, y would be equal to 3 halves times 4. Or 3 halves times 4 over 1. You can always put any number over 1. It's still the same number. 3 times 4 is 12, and that sits over 2 times 1, which is 2. But what does 12 halves reduce down to?
6.
6.
So what's another ordered pair or point that I've generated for this equation?
4, 6.
4, 6. Now we're in business because look at, we have 3 unique points. 3 unique points, ladies and gentlemen. That should be enough to graph y equals 3 halves x, okay? So let's go to our graphing paper and plot those points and see if we can get a graph. This line here, okay? Let's see, I'm exhausting my graphing paper here. So I'll squeeze one in right, let's see, right about here. Let me get one in here. Okay. All right, 0, 0 is both the x and the y intercept. Do you agree? The origin is both the x and y intercept. What's another point? 2, 3. How do I plot 2, 3?
You move 2 to the right, right?
Yep, and then what?
Up
Two.
3.
Up 3. 1, 2, 3, right there. There's 2, 3. There's 2, 3. All right, and then we want to plot what? 4, 6. How do we plot 4, 6? Start at the origin, and how do I move? 4, 6.
4 to the right.
1, 2, 3, 4, and then what?
Up 6.
Up 6. 1, 2, 3, 4, 5, and I'm going to put it right here. Next tick mark would be probably right there. Okay, there's 4, 6. Take a ruler, put a line through these points, and we have the graph of y equal to 3 halves x. There you go, ladies and gentlemen. That would be the graph of the equation y equals 3 halves x. That's its graph. All right. Notice the x and y intercepts happen to be the same point, namely the origin 0, 0. That's where the line crosses both the x and the y-axis. That's why that point is the x and y intercept of that graph. Okay. All right. That makes sense how we graph that one, despite having to find 2 other points in addition to our intercepts. 2 other points. We had to because our x and y intercept were the same point, namely the origin. I'll be honest with you, Liz. Let me show you a little shortcut here. Wait a minute, hold on. Okay, in general, that's always going to be true. Whenever you have a linear equation that looks like this in general, where y is equal to some number c times x, both the x and the y intercepts will be the same point. They're always going to be the origin 0, 0. C is just some number. Whenever your linear equation looks like this, your x and y intercepts will always be the origin. Okay, for an equation that looks like this. In general, it's always true. So do you agree that for all of these equations, 23 through 28, the X and Y intercepts are all going to be what? The origin? 0, 0? Do we buy that? For every one of these equations, 23 through 28, the X and Y intercepts will all be the origin.
Yes.
Yes.
Yeah, okay, here we go. All right, ladies, I'm just have a little bit of fun now. Problem number 44. What would be the y-intercept of this linear equation? Number 44, the y-intercept.
0, 5,
0, 5.
43, or 44.
The
Problem
y
40.
intercept
Yeah.
will be 2.
Yeah, for problem 44. The line, the linear equations graph, this red line crosses the y-axis at what point?
0, positive 2.
0, comma 2, exactly. So 0, 2, that ordered pair that I'm pointing to right here would be the y-intercept. What's the x-intercept of this linear equation?
Negative, what's that? Negative 5,
Yeah,
0.
negative 5, 0 would be the x-intercept right there, that point on the x-axis. Negative 5, 0.
You said the y was what?
The y-intercept for number 44 is 0, 2. The ordered pair is 0, comma 2. The x-intercept is the ordered pair negative 5, comma 0. Negative 5, 0. That's the x-intercept. Number 43, what's the y-intercept for 43?
Is it 0, 5?
You got it, 0, 5, right up there. What's the x-intercept?
0, 3.
Not 0, 3, but what? 3, 3, 0. Yeah, 3, 0 is the x-intercept. Remember, it's always x coordinate first, then y coordinate. All right, number 46, what's the y-intercept for 46?
Zero, negative 3.
0, negative 3. What would be the x-intercept for number 46?
Negative 5, 0.
Negative 5, 0. Correct? All right, number 45. What's the x-intercept for 45? X-intercept.
0, negative 1.
Not 0, negative 1.
X. I mean, negative 1, 0.
Negative 1, 0. Yeah. What's the y-intercept for 45?
0, negative 3.
0, negative 3. You are correct. All right. All right, let's try a couple of these problems. Number 48, it says graph the line that passes through the point negative 3, 4 and has a y-intercept of 3. What is the x-intercept of this line? Okay, so we're going to try 48. Ladies and gentlemen, you really need to use graphing paper for these problems here for accuracy. Without graphing paper, you might have a difficult time answering the question accurately. All right, so problem 48, what do they tell us? They tell us that the line must contain the point what? Negative 3, 4? And its y-intercept is to be what? Y-intercept, yeah, the y-intercept is supposed to be 3, but what would that be as an ordered pair? If the y-intercept is 3?
0, 3.
0, 3. Okay, so here's what we're going to do here. This is problem 48. They give us a point that lies on the line. They also indicate the y-intercept of that point, of that line, excuse me. And they want us to graph the line and also determine the x-intercept. We're going to do that. So let's make ourselves a graph. And like I said, graphing paper really should be used for a problem like this for accuracy. If you try to freehand draw your XY coordinate plane, your tick marks may not be evenly spaced, and it might be very difficult to accurately answer this question. So what we're going to do here is we're going to draw ourselves an accurate XY plane. All right, ladies and gentlemen, so what are we going to do here? What help me out with this problem? What am I going to do? What do I need to do here?
Plot the points.
Yeah, we're going to plot these points. They tell us the line must go through this point or pass through this point, -3, 4. Let's plot that point. How do I plot -3, 4? Start at the origin, and how do I move?
3 to the left,
And then what?
up 4. I
Up
believe.
4. 1, 2, 3, 4. There's the point, -3, 4 in the second quadrant. Quadrant number 2. Okay. So that's our point, -3, 4. Now what? What do we do after that? We plotted that point. What do we do next?
Plot 0, 3.
Yeah, we got to plot the y-intercept, 0, 3. They told us that's what it was. Start at the origin, and how do I move to plot 0, 3?
Three to the right.
Oh, wait, do we go 3 to the right?
Oh, well, you
No.
said you're, oh, 3
Okay.
up.
The x coordinate is 0. We don't move right or left. The x coordinate is 0. We just
Move
stay on the
3
y-axis and we go up 3, don't we? 1,
Mhm.
2, 3. There's the y-intercept. No, you don't go 3 to the right. If you go 3 to the right, that'd be an x-intercept. Do you agree?
Yeah.
That's not an x-intercept. That's a y-intercept. All right. So there's 0, 3. Well, we'll take a ruler now. And ladies and gentlemen, what we're going to do is we're going to put a line through these points. And we're going to hopefully see if we can determine what the x-intercept must be here. If we can even read it off. I don't know if we're going to be able to read it off, but we'll try. So I'm going to put a line through these points. Be very careful to make sure the line goes through the center of these points, or else a little bit of a difference in slant could adversely affect your ability to read off accurately the x-intercept. So there's the graph. Now, it appears that the x-intercept is what? You know, I didn't put my line dead center through these points, ladies and gentlemen. I didn't do a very good job. You see why I got to use graphing paper for accuracy here? Because otherwise we might be a little off. And it don't take much if you're a little off. What does the x-intercept appear to be? It appears to be what, this point here? Can anybody read off that x-intercept for me? What would that be? 1, 2, 3, 4, 5, 6, 7, what? 8? It looks like my x-intercept might be 8 what? 8, 0? Is that what it looks like, ladies and gentlemen? 8, 0?
Why is not 0, 8?
Oh, because 0, 8 would not lie on the x-axis. The ordered pair of 0, 8 would be on the y-axis. That would be up here. 1, 2, 3, 4, 5, 6, 7, 8. 0, 8 would be way up here. That's 0, 8.
Okay, I see.
This is 8, 0. Do you agree? Remember, it's x coordinate first, then the y coordinate. The x coordinate's 8. That's why I moved 8 units, not along the y-axis, but the x-axis, correct?
Okay.
That looks like my x-intercept, 8, 0. All right. So you can see why graphing paper is a necessity here, because you can see if you're a little sloppy in drawing your graph, you might be very hard pressed to find accurately what the x-intercept is. Okay, so graphing paper is important. Look, even with graphing paper, I made a little mistake. Do you agree? My line was a little too high here. It should be going through 8-0 there. So even with graphing paper, it could be tricky. You got to be very careful when you draw your line through these points. You got to make sure that your ruler, okay, is going to have you drawing those the line precisely through the center of both points. If you're off a little bit with the slant of your ruler, ladies, I'm just a little bit of off. You're off just a little bit. That's gonna really adversely affect where your x-intercept is. Do you agree? If you're off just a little bit. All right, so you got to be very careful. All right, that was number 48. Let's try another one here. That was an interesting problem. Liz, I'm just trying number 50. Let's try one like number 50. It says a line passes through the point 3,4 and has an x-intercept of 1. Graph the line and also name its y-intercept. Okay, problem 50. What do they tell us? They tell us that a line is to contain or pass through the point 3,4. They also tell us that the x-intercept is 1, or as an ordered pair, what would be my x-intercept? Would it be 0, 1 or 1, 0? What would be the case? 1, 0 or 0, 1?
0,
What's that?
1, 0.
1, 0, 1, 0. Not 0, 1. 0, 1 is going to be a point on the y-axis. They tell you that this is not a y-intercept, it's an x-intercept. It has to be a point on the x-axis. So it has to be 1, 0, not 0, 1. You got to get that correct. All right, so here we go. We're going to make a graph. All right, our graph here. And again, graphing paper along with a ruler would be very wise for neatness and accuracy. All right, help me plot the point 3,4. How do I plot 3,4? The line must contain this point or pass through that point. How do we plot 3,4?
Move over 3 to the right.
1, 2, 3 to the right, and then what?
Or
Up 4. 1, 2, 3, what, 4?
I think so.
You are correct. All right. And so, ladies and gentlemen, there would be the point 3,4. And they tell us that the x-intercept is what?
1.
1, 0. So I started here, and well, how do I move?
Just over 1.
1 to the right. That's my x-intercept, 1, 0. Take a ruler and put a line through these points. And they want us to accurately graph this line. That would be the graph. And what does the y-intercept appear to be? The y-intercept. Where is my y-intercept?
-2.
Yeah, it's right down here. 0, -2. -1, -2. That's your y-intercept. That's your y-intercept. This was your x-intercept, correct? Is this making sense how we're doing these problems here?
How did you get your y-intercept?
Well, it's where the line intersects the y-axis, and it intersects the y-axis at what tick mark? Right down here, -2,
Okay.
-1, -2. That's my y-intercept at -2 there. Okay. That's the y-intercept. All right, so these problems are interesting, to say the least. Okay, so let's see here. All right, therefore, what I would like you to, let's see here. What I would like you to do is for classwork number 2 is I want you to do problem number 52. Or I'll tell you what, I'm going to do 52, and then I'll give you a classwork number 2. Okay. All right. I'm going to do number 52, and then I'll give you classwork 2. All right. What do they tell us about number 52? It says that graph the line that passes through the points of 5, 3, and -3, -5. A line must pass through those points. I'm going to write those down. And it says, not only are we to graph this line that goes through those points, but we also need to determine then the x and y intercepts. All right, so let's see if we can do this problem. This is number 52. 52. A line must contain these 2 points. So I will make my XY plane here. Oh, that's a little off, isn't it? That's already an error. So that don't look good from the get-go here. I better not use that. That's going to be an error. Okay, so disregard that. All right, let me make another axis here. So I'll make it right here. All right, and now I need an x-axis. Just plot these points. How do I plot 5, 3? Start at the origin, and how do I move?
To the right, 5, up 3.
1, 2, 3, 4, 5. Now up 3. 1, 2, 3. Right there in the first quadrant is the point 5, 3. Okay, so that's 5, 3. Good. Now how do we plot -3, -5? Start at the origin, and how do I move? -3, -5.
To the left, 3, down 5.
To the left, 3, down 5. -1, -2, -3. Now down 5. -1, -2, -3, -4, -5. Right there. There's the point -3, -5. Take a ruler and let's put a line through these points here. Try to be accurate. Make sure your line goes, right through the center of these points here. Otherwise, we might have a very difficult time trying to read off the x and y intercepts if we're sloppy. That would be my graph to the best of my ability. Ladies and gentlemen, can you read off the x-intercept of this line? The x-intercept? What does it appear my x-intercept is?
2, 0.
2, 0. 1, 2, 2, 0. That's my x-intercept. What's my y-intercept?
0, -2.
0, -1, -2. 0, -2 appears to be my y-intercept. Do we understand how we got these intercepts here? 2, 0 is the x-intercept. 0, -2 is the y-intercept. Now I will give you classwork number 2. This is the last classwork for today, ladies and gentlemen. I would like you to do problem number 51. I want you to graph the line that passes through the points -2, 5, and 5, -2. And I also then want you to determine clearly what the X and Y intercepts are. Problem number 51, classwork number 2. Go ahead and do that. Anybody need more time? All right, anybody get the x-intercept? What does it appear the x-intercept would be?
0, 3,
Is it 0.3 or 3.0?
3, 0, 3, 0.
Right.
Yeah, you got to get the order correct. That's your x-intercept. That's 3.0. X-intercept. What's the y-intercept?
0, 3.
Now the y-intercept would be 0.3. 1, 2, 3. That's your y-intercept. That's your y-intercept. Are we getting this, ladies and gentlemen? Are we understanding what x and y-intercepts are?
Yes.
Making any sense here today? Section 3.3. All right. So in a nutshell, that is 3.3, ladies and gentlemen. I think we've exhausted all the problems that I want to go through. That's all I have for section 3.3. And let me see. Hold on one second here. See if there's any application problems here. Well, applying the concepts, let's see. I don't know if these are not really going to help us too much with the concepts. They're just way too advanced there. Okay. All right. So that's, I'm willing to call it quits for today here, ladies and gentlemen. I think we covered everything we need to cover out of 3.3. I will update the homework assignment out of 3.3 and of course post solutions for 3.3. And yeah, just make sure you try to get that exam done by midnight Friday night, the chapter 1 and 2 exam. And also turn in what I requested for your homework by midnight Friday night. And if there are no other questions, then I will let you go. You guys have a great weekend.
Position. Regretted it till they put everyone under the prison.
Right.
That's like one of 100 times.
I think somebody's already having a great weekend.
You leave 51 up for a minute.
What's that? 51?
Yeah, if you leave that up.
Yeah, I'll leave this up here. Okay. All right. So there you go, ladies and gentlemen. Have a great weekend.
Hey, Mr. O, it's not about class, but did you grade the classwork for on the 11th?
The 11th. No, not yet. No, not yet. I haven't.
Okay, thank you.
Okay. So I'm going to get to that. Okay. All right. Any other questions? All right, ladies and gentlemen, have a great day.